Hello everyone. Today we are going to see problem number 199 of Leetcode. So let's first go through the problem statement. So basically it says, given the root of a binary tree, imagine yourself standing on the right side of it and return the values of the node you can see ordered from top to bottom. Right, so basically what it is trying to say, let's say we are given this binary tree, right, and let's assume that you are standing on the right side of it, right? So which nodes you will be able to see, you have to return, you have to print those, you have to return the node, right? Print or return those nodes. So basically what I can see, I can see the node 4, I can see the node 3, I can see the node 1 from the right side, right? So basically I have to return in the order from top to bottom. So let's say for the first node, from the top node that I can see, then the first node or the top node that I can see from the right side will be 1. The next node I can see will be 3. And the next node or the last node will be 4. So I can only see 3 nodes from the right, and I will return in the form of array. So what I am returning? 1, 3 and 4, ordered from top to bottom. So I think the problem statement is pretty much clear. Let's go through the approach. And approach, as you might have guessed, is very similar. So it will be a level order traversal, basically a modified version of level order traversal, right? So I have taken an example here. So what are you going to return? We are going to return a vector 3, 5 and 2. So this will be our answer, right? And let's say the tree is empty or the root node is null pointer. In that case, this array will be empty, right? So we will do a if checking in the first, if the tree, if the root is a null point or not. So if the tree exists or the root exists, then only we go forward. So what is our approach? As we know, in the level order traversal, we use queue data structure. So let's first take a queue. Queue of address or address of nodes, right? And we know queue is a first in first out data structure, right? I'm assuming that you might know that queue is a first in first out data structure. So first let's push the root node. So I will write a node in front of this value, so that you can assume that it is a address, right? It is not a value, it's a address. So node 3, root element is 3, root element contains the value 3, so I return node 3. And in the next I will push null pointer in the queue. Okay, now what I will do, I will pop out the first element. So what will be the first element? First in first out. So node 3, first node will be popped out. Okay, so I will check, so I will store it in a temporary variable, let's say temp. So what is the value of temp? Temp is a node, temp pointing to node 3, right? So I will check if the front element in the queue is a null or not, right? Is it a null? In so I pop, so in the queue only one element is there and it is a null, right? Since it is a null, I will push, let's say I am assuming answer to be our final vector, the vector that we will be returning. So now first, initially it is empty. It will check first if the queue, the front element of this queue is a null pointer or not. I've checked, and yes, it is a null pointer. So what I will do, I will push answer and I will put the value at this temp node into this answer vector. So I will push the value at the value of temp, it will be 3, right? And next we will check if it contains if it contains the what you call left child. So temp is a node 3. Node 3 has a left child. Yes, it has a left child. So I will push it into this queue. It will go right like this, node 4. Okay. and then I will check for the right, if the right child is present or not. Yes, it is present, and I will push node 5. Again I will pop out this one. So now the temp becomes, so now temp becomes what? Now temp becomes null pointer. So since temp is a null pointer, now I will check if the size of this queue, if the size of this queue, if the queue is not empty or the size of the queue is greater than 0. So I will check, yes, the size of this queue is, yeah, greater than 0. So I will push null pointer again. So are you understanding what is the null pointer doing? Null pointer is marking a end to this level. So at this level it is marking an end. When I reached 4 and 5, to mark that this level has been ended, we are using null pointer, right? Null pointer will again come when we push 6, 1 and 2, and then null pointer will come. So basically what is the job of this null pointer? Null pointer is just is telling us that this level has been terminated here. Okay, I hope you are getting it. So yeah, the work has been done for this node. So I will go to the next node. Okay, I will pop out the then node 4. Okay, so it is not a null pointer, as we can see, it is an address. So what were we doing? We were checking if the front element of the queue is a null pointer or not. Is it a null pointer? No. The front element of the queue is what? Node 5. It is not a null pointer. So no, you can't push any element into the answer array. And nextly, we will check if it contains left child. Does the node 4 contains left child? No, does not contain. Does it contain the right child? Right child? Yeah, right child it contains. So we will push node 6 here. Okay. And this iteration ends. So now we will go to the next element. We will pop out node 5. Okay, we have popped out node 5, and we will check if the front element of this queue is a null pointer or not. So yes, it is null pointer. So basically what we are trying to do is we are checking if the next is a null pointer, or we are checking if the level has been ended or not. Here we are checking if this level has been terminated or not. Here also we were doing the same thing, right? So we are checking if the level has been ended or not by checking if the front element of this queue is a null pointer or not, right? So yes, the level has been ended since a null pointer is there. So we will push the value at this node. And what is the value at this node? The value is 5. Okay, and the next thing we will do, we will check the left and right child of this node, right? So left child is what? Node 1, this node. What is the right child? Right child is node 2. Okay, so the iteration for this also ends. Okay, now we will pop out the next element. What is the next element? Next element is null pointer. Okay, what are we supposed to do? We are supposed to check if the queue size is greater than 0. Yes, the queue size is greater than 0 means the queue size is greater than 0, and so we have to push null pointer here. Why are we doing this null pointer again? So we are marking the end of this level. We are marking the end of this level. Sorry. So what we are doing? We are marking the end of this level, right? This level, like 6, 1, 2, and then null pointer. So basically null pointer is marking the end to this level. So temp equals to null pointer. So job has been done. I put the null pointer here. So this iteration is also ended. Now I'm going to next element. What is the next element? Node 6. Okay. What are we supposed to do? We are supposed to check if the front element of this queue is null pointer or not. It is not null pointer. Does it contain left child? No. Does it contain right child? No. Iteration ends. Next, it will pop out node 1. Okay. So I will pop out node 1. And what I am supposed to do? I am supposed to check if the level has been ended or not. Or we can also, or in other words, we are trying to check if the front element of this queue is a null pointer or not. So what is the front element of this queue? It is node 2. So no, it is not null pointer. So again, we are not going to push anything. And then we are going to check if if it has a left child or right child. No, it does not have left or right child. So yeah, here the iteration also ends. Okay. So what is the next node? Next node is node 2. So node 2 is there. What are you supposed to do? We are supposed to check if the front element is null pointer or not. Yes, it is null pointer, or in other words, the level has been ended, and since the level has been ended, we know that it will be the rightmost element, right? So for node 2, it is the rightmost element. So we are going to push it into our answer vector. The value at this node, which is 2. We will check if it has left child. No. Does it have right child? No. Iteration ends. Then we are going for the next element of this queue, or the last element of this queue, null pointer. At this point, so whenever a null pointer arrives, what are we supposed to do? We are supposed to check if the size of this queue is greater than 0 or not. So the size of this queue is obviously 0, since all elements have been traversed. So we are not going to do anything, because as you can see, the tree has already been traversed, and there are no elements left to traverse, right? So we can't do anything. So yeah, and this is the answer that we are getting. I hope you are getting my approach, why we are using null pointer. We are using a null pointer to tell this that this level has been ended. This is one level, this is one level, this is one level. So just to tell that this level has been ended, we are using a null pointer, and we are checking if if the front element of the queue is a null pointer or not, to check if it is the rightmost element of this level or not, right? Okay, so let's go to the code. Okay, so I will first I will check if the root exists or not. If root does not exist, I will simply return a empty vector. Okay, then I will declare a vector. Let's say I name it ans. Okay, then I will declare a queue data structure which stores the address of the tree nodes. Okay, let's name it as ADR. Now let's first I will push the root node, adr.push root. Then I will push the null pointer to mark the end to this level. So in the first level there would be only one element, right? So we will push the null pointer here, and I will create a temporary variable, temporary pointer temp. Okay, now I will go create a while loop, while adr dot size, or you can say not adr dot empty. Okay, I will pop out the first element, temp equals to adr dot top, adr dot front. Okay, and then I will pop out this element. So there are two cases. First case, as you can see, first case will be the root will be either an address or it will be a null pointer, right? So let's say if temp, or if the root if the address is present. So if temp is there, if temp not equals to null pointer, what we are going to do, first we are checking if adr.front, if the front element of the queue is equals to null pointer. Is it a null pointer? If yes, then push it into our array. What will be this? Temp value of this temp, right? Next, what we are going to do, we are checking if this node has left or right child or not. If it has left child, then push it into this queue. Okay. Right. And then we are checking if it has right child or not. I think I have done something wrong there. Okay. Sorry. Okay. adr.push root right. Okay. What if the temp is a null pointer? In that case, we will simply check if adr dot, if not adr dot empty. Okay. If the adr is not empty, we are going to push null pointer, right? That's pretty much it. Let's say I will finally return the answer. Let's run this. I hope it will not give any error. Time limit exceeded. Okay. And why is this happening? Okay. Why is this happening? Root left, root right. So sorry. I think I have done it wrong. It should be temp, right? Sorry. Now it should run fine. Yep. Yeah, it's running fine, right? Okay. So let's submit it. Yeah. Okay. Yeah, it's running fine, and as you can see, it's faster than 100% first time. Okay. So yeah, that's pretty much it. That's pretty much it, right? Okay. So yeah. So thank you for viewing the solution. I hope you understand the solution and my approach. Thank you.